Yeah, Thomas is coming too. Hi. Hey, Thomas, good evening. We just started.
Evening.
Good evening. Okay, yeah. So as I said, I was telling to Angela that what I'm gonna do that pretty much starting this week, I'm gonna go through that. Jonathan, he's heading to. Hey, Jonathan. Good evening, and good to see you. Good to see you. Good to hear you.
Good evening, sir.
Okay. So that what I'm gonna do starting this week, that pretty much throughout this whole week, I'm gonna go through the homework and midterm. While we going through that, if we see some kind of a theory, I'm gonna cover the theory rather than cover the theory and get back to the do the homework. I go other way around, reverse. And then in that way that you guys know how to answer the question, how to write the description, and then sometimes some theory not that much important to you because that not going to be that much useful. So because of that, what I thought was that just to get back to homework, while go through pick homework, and plus that we can pick some exercises from that those are PowerPoint slides as well. In order to support that one, what I was telling to that Angela that I created a module. I'm gonna share that screen. Okay, you can see. Uh, See, I created a new module called data. See, in this one, you can see that data related to chapter 2, chapter 1, 3, 4, 5, 6, 7, I think 8, 9 or 10, I think like that. Pretty much that those are that are useful for the contents that's available in PowerPoints. Excuse me, you can remember that. Let's say, for instance, that last week we were talking about chapter 1 through 3, the slides. They were here too. See, if you go to, can looking from here, it's another way to see. See, these slides, PowerPoint slides. Okay, this one I don't think anything. And then they have example. When they talk about example, you wanna see that which data set they show 5 results of a random sample through mutual fund. It's not given over there. Just keep going. Keep going, keep going. I don't think anything not available here. Maybe that chapter 3. I think it's going to start from chapter 3. Yeah, there you go. See, the work manufacturing company was concerned about the cost of adding nodes to communication network. They obtained data on 14 existing nodes. That data, they don't tell about that one, but down the road, they're going to talk about that one again at a certain point. I'm pretty sure it should be somewhere. That's how. This one. See, 5 sin of communication nodes. That's the data set, actually. That's the data set. They were working on that, the same data set here and there. That too. Yes. This data set, you don't have that one. Now you have. See, Fort Worth Manufacturing Company was concerned about the cost of adding nodes to communication network. They obtained a data on 14 existing nodes. So that one is related to this data set. See, nodes, from nodes. Download. See, that's the data set. See, they say that there are 14 nodes and their cost, see, number of ports, and then the cost. So like that. Okay. So they were related to that. They are related to the contents available on that PowerPoints, and then they were talking about some examples. When they go through the example, they were citing they were using some data. Those data even here, so you're not gonna miss anything. So by any chance that while I'm going through the homework as well as those things, you can do on your side too, that open this one and then run everything and work on that one. That's one thing that I want to show you. Let's get back to a little bit in the chapter 3, mainly that we covered that how to import data. Okay, V part, this is okay. And how to draw a scatter plot. See, this is the scatter plot drawn related to that slide that you saw. Sorry, not this one. Little bit discussion. This one I think should be somewhere here. It's gonna start for the first time here. There you go. See, this scatter plot. See, that's the scatter plot in order to the cost versus the number of ports. See, the cost, the scatter. I had a data that already that I created that some kind of library called data out, and then I called that data. It was in this folder in my flash drive that I'm gonna take this one. It's called common. See, com nodes 3. That means 3 stand for the chapter 3, and they were in that the CSV. And then I'm gonna bring this one and put it into this folder, and then work with this. So then we drew a scatter plot related to this one. Related to, I think it's easy for me to get a PowerPoint separately from my one. It's in week 1. It's related to, oh no, not that one. This one, see, that one. Cost versus number of ports. That's the one that we were trying to get it over here. See, it's G plot and data. I'm going to call data out. This one scatter. See, my plot would be scatter. It's not a scatter plot matrix, just a simply scatter plot. Scatter. Then later on, then this one, let's use this way too. Let's say that if you use the SG plot and the data and the rig, see, regression instead of this one, what's going to happen? See, SG plot and then rig. You're going to get this regression line. That's how you're going to get the regression line. See? That's how you're going to get the regression line. See? In those days, long time ago, this book was written like almost 20, 30 years ago. That time that he was using Minitab. We don't use Minitab. It's a very, you can consider this like a very primitive tool or package we don't use. But there are some people who are using that one, but we are trying to use the SAS, Python, R, Julia, say Java, JavaScript, C++, C, all those kind of heavy programming languages. Okay, MATLAB. Right, that's how you're going to get that regression line. Same thing, scatter. Take out the scatter and you put the rig, and this is the y coordinate, this is the x coordinate. Okay, now let's start. SG plot, scatter and rig both together. See, one shot you can get that one if you're going to add these two together. See, in one scatter and reg both. Reg means like you're going to have like a regression line. Okay. So this is kind of a thing we're going to do in R language. You do in a different way. R language you do different, but in SAS you do like this. But if you learn that both 2-3 languages in the data analytics, it's going to be very useful. R, Python, Julia, and SAS, and MySQL or SQL or anything. Those things are important too. Okay, so that's that one. Then a little bit go further down. Then we explain this one in large scale. Let's say that related to this one, little bit keep you in head. I want to explain you something here, just a little bit. The cost versus nodes. See, cost versus node. This is not what you see here. Look at this is not what you see here. Okay, it's not that. How come they differ? They were talking about the same thing. Look at the same thing, cost versus number of ports. But here, we don't have that scatter plot. These dots we don't have. Okay, for a given 12, see, here, given 12 somewhere here, you have only one data point. See? Okay, 30, you have maybe like a one data point, or maybe none. See, 50, see, again, 68, around 68, maybe it's like a one data point. See, one. For 30, look at the 30. If you go this one, see, sometimes you may or may not see, looks like that. Is that the one? I don't think so. Okay, let's say that you have if you have at least one, only one, not two. But here not like that. Look at the same thing. Number of ports. There's a straight line too. See, there's a straight line, there's a straight line. You know this one, we're gonna how do you denote? Y hat equals B naught plus B1x. This is not that. This is a population version. This is a sample version. This is the one that I was drawing. For a given 12, for a given 12 nodes, they believe that your cost gonna have like a values, infinitely many values. Infinitely many values. All the infinitely many values, they have put it into a distribution. You know, when you have infinitely many values, you can draw a histogram and you can draw that smooth curve like that. See, and you get the center of that distribution. So do with this guy and this guy. Those centers you're going to combine by a line. It's called the mean. Mean equals to beta node plus beta 1 nodes. It's going to be not like that. That means expected value of cost. Expected value of cost given nodes. For a given nodes, expected value of cost going to be in this format. For a given, that's the idea. That's the idea over there. That means that here, see, we'll get an idea. See, here that in population version, that these are nodes. This is the cost. This is Y. This is X. So given this one, you have a graph like this. You have a graph like this. You have a graph like this. You get the centers. They are center, center, center. See, how do you denote the center? Center is, you can go to center. You go to general case, you don't have to go to all these. You can denote like expected value of cost given nodes, given. That line means that one. So your equation should be expected. E stand for expected. Expectation of, if you do this one in a long run, what are you going to expect? What is the average cost? What's the average losses? What are the average profit? What's the average that margins like that? Okay. So expected cost given. This means given. For a given nodes, number of nodes is given by this model, beta node plus beta 1 times nodes. That's what they say. That one, since this is unknown, this is unknown. These two are unknown. Unknown, these are called unknown parameters. They were unknown. You don't know them. But one thing you can say clearly, they fixed. We have only one value. Since we don't have this one, this is called the population version. Population version. That's the population regression line. See, population regression line. See, it's the population regression line. See? Population regression line gonna go through the centers of all the distribution expected. But in sample, it's not the case. You have a nodes here, which is x. You have a y here, the cost. You have a scatter plot like this, and you're gonna have a line like that. Then you're gonna see cost, estimate of the cost, not the expected value of the cost, estimated cost, estimated value of cost. It's given by b node plus b1 x, sorry, b1 times the number of nodes. Sorry, you cannot see here. Times nodes. B naught and B1 are known. We know that. When you run regression, we can easily get those values. This is nothing but sample regression. Sample regression line. That's what they were. That's why we have this one here, but this one there. See? So we'll go through that one. Get this one. Now go through this one. Now you want to find. You go to the codes. We ran the regression. You see, we ran regression, cost, number of ports. See, CLV, CLM, CLI. Let's say what this means. Let's run. This is what I'm interested in. Look at what I got. Look at what I got. I have a confidence level. Confidence level. CL stand for the confidence level. CL stand for the confidence level. CL stand for the confidence level. I have three types of confidence level. Confidence intervals or confidence level. One for B values, one for mean value, one for individual values. See, for three things. See, sometimes you are interested in the confidence interval for your parameters. This is a confidence interval for beta naught and beta 1. So, beta naught. Beta naught and beta 1. I'm talking about this. See, confidence interval. So this guy, see, this guy, confidence interval. This is called the point estimate. You say, I don't need the point. Give me the whole bunch of values for beta nodes. So that's what we are trying to do over here. This is for the average. Can you remember I talk about the mean here? You can estimate this guy too, this part. You can find the estimated value of cost given nodes. That one. Or you can find the what is that average cost for the individual. See, individuals. The individuals. See, for the individual, this for the mean, this for B. What that means, look at here. You don't have to worry about that formula. So if you go over here, this is for the B value for the confidence interval. We don't have to worry about those formulas. They're going to calculate everything for us. And this is for B1. And this is for B naught, the confidence interval. Okay. Then later on, in other ones, see, the other one, if you keep going, see, I'm gonna go up to here, come here, see, come here, see, here, here, little bit up, 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 up. See here. Now they say that. See, we give the confidence interval. Confidence interval for the mean value of y, mean value of cost at this point, at for given this certain number of values, certain number of nodes. If you are really interested in confidence interval for the estimate for this guy, for this guy, that means that expectation of the cost, average cost, see, average cost. If you really want to do the some kind of a estimation for the average cost, you can do that estimation. That estimation two types. One is point estimate. The other one is on interval estimate. You say, give me a whole bunch of value for the average cost for given certain number of nodes. They say they are here. They were talking about XM would be the given node. Let's say 40 nodes. Okay. 40 nodes you can calculate by plugging into that one. Those are the values they calculate on that one. See, those are the values they calculate on this one, CLM. And on the other hand, what is this one? CLI. Let's look at the CLI. CLI would be, see, they calculate for 40 nodes. See, give me the average. This is for the test. Forget about the test, but we're going to say that give me the average cost of estimate. Okay, we don't know the average cost. We don't know average cost. There's no way you can find the average cost because everything will be done based on the sample. So you're going to say, I can give you an estimate for the average cost for given certain number of nodes. They say, okay, 40 nodes, how much it's going to cost on average? Give me an estimate. See, they try to get the estimate. That's what they were trying to do in this one. Give me an interval in a certain range, not like I just say simply say, okay, it's going to be $5 or something like. Just give me a range, like $0 to $10, like that, including that $5 within that interval. Give me a range, okay, like that. So on the other hand, they want to do something like this. So they want to write the interval for that, see, estimate of y, the cost, not the average cost. The estimate of the cost, this one, individual means you don't go to the average you're going to get by adding everything and divided by number of that observation. But instead of that, you can say simply give me the average cost. Not the, sorry, simply give me the estimate of the cost. Estimate of the cost. That's the one that we're going to calculate by this one, which is related to this one. See, y hat. It's not this one. See? So this means, so this one, if I write this one a little bit for you to get a clear idea, rough idea. I don't write the equation here. I'm going to say CLB for the confidence intervals for beta. That means beta naught and beta 1. Their confidence interval. Okay, confidence. CLM for the confidence interval for this guy. Expected value of cost given the nodes. So that average cost expected means average cost. This is the average cost. Average cost. Average cost per given nodes. Average cost. Simply you can say average cost. Give me the confidence interval for average cost. This one, what? Give me the confidence interval for what? Marginal cost. Marginal cost. Marginal cost is nothing but beta 1. You know that. That's a marginal cost. Give me the average, the marginal cost. Confidence interval for marginal cost. Okay. Beta means beta 1. The beta naught means like a cost for cost when there are no nodes. Okay. So the cost for 0 nodes. is beta node. So if you are looking for those two, you're going to find the confidence interval for betas. You don't do anything by calculate. Some people, they are really want to know the marginal cost. Some people really want to know marginal cost means like that the cost per number of nodes, or that increment of the one node, 1 unit of the node. By increasing one node, how much it's going to cost for you to increase one node. That's called the marginal cost. Or you can look in for the cost for 0 nodes, which is beta node. So it depends on whether you know the confidence interval for beta node or beta 1, or you need the average cost. Or the other one is called the CLNI. You're going to say, I need the confidence interval for expected, sorry, not expected, cost. See, estimate cost. This guy. This guy. Cost. What's the average? See, this one. That's why estimate or just simply that guy. Okay, sorry. Confidence interval. See, confidence interval of interval for cost. I'm going to say cost. That's it. Cost. Cost. If you want, you can add cost per nodes, but it's simply cost. But sometimes they're going to give you how much that M would be related to that XM. You can relate this one to XM to see 40%. 40. So therefore, I'm going to write here a little bit clearly. Cost per node. Cost per node. That's the CLI. So 3 types of confidence interval. Some people interested in average cost, not only average cost interval. Some people in completely cost only, cost per nodes. This one cost per nodes too. See, cost per nodes, but expected average cost per nodes. See? Per nodes, given nodes or per nodes. You can say like that. This one you can say per or given. Nodes, number of nodes has been given. Based on the number of nodes, you're going to decide your cost. You can estimate. You need the estimate. This estimate is confidence estimate. Confidence estimate is a point estimate. You're going to utilize the point estimate to get the confidence. Those are the 3 results you're going to see here. See, this is for the average for a given. See, this is your dependent variable. See, based on this value, predicted value, this is a dependent variable. Dependent variable means this is your y value with your cost. This is your cost. This is the estimated cost. This is the interval estimate. This is the interval estimate. This is the interval estimate. This is the interval. It's a point estimate. See, for what? For the average cost per given certain number of nodes. This is what. See, this is a predicted value. See, they are mean. That means that that's the mean for the individual. This mean, this confidence interval. This confidence interval is the second one. See, they are predicted value how much? This one. Again, predicted value this one. But you're gonna utilize, but you have a 2 concept, okay? Same value being utilized within the same concept. Sometimes you ask for the average cost. Give me the estimate of average cost. Give me the just the cost. Estimate of the cost. See? As an interval. As an interval. See? This is the estimate for both. See? This is the estimate for both cases. Average or doesn't matter. If you're interested in average cost, individual cost, we're gonna have the estimate only one estimate. That's why we have this. This is the beauty of that one. See, that's the beauty of that one. So that part being utilized to talk about 2 things: two things. One is average cost, estimate. Okay, estimates. We are talking about the estimate. See? This one, this one. No, they haven't written over here, but I don't want to write the equation. This see, it's the same thing. Only thing SM. We write the SM is only thing by changing this one. See, SM has been given like that. So earlier you write like this. See, this is for the see average one. That one average one. That one is for the see average is for the average. Sorry, individual is for the individual. This one for the this one for the average. Two things. But look at this is for the average estimate. You can get the estimate for this guy. You can get the estimate for just simply for that guy. For both cases, you use the B naught. That's what I'm trying to say. See, same guy has been utilized to talk about two things. Only thing gonna change the standard error. We don't go to detail on that one. That means that simply they are trying to say that if you wanna that estimates, see, look at what they're gonna do. Interesting thing. Point estimate. See, predicted value. Predicted value. Predicted value means estimated value. Estimated value of cost. Value of cost. Cost. The estimated value of the cost has value of cost. Let's say that for a given this one say, has been given say predicted value 68,805. 68,805. See 68,805. See 68,805. So that one has been given based on the where's the number of nodes. Now we have to find out the number of nodes related to this guy. Okay, I'm going to go to original data set. My original data set. Let me see what is the number of nodes related to this guy. Okay, number of nodes. Let's figure out number of nodes. Okay. I just opened that one. I go to this one, open data. That's for the common nodes here. See, look at the number of nodes, 68. Look at the true value, 52388. 52388. This is the predicted value for the cost. They haven't mentioned about the cost, the number of nodes, but you have to get it from here. Okay. That means before that one, I draw this one here. That means this one. That's what they are trying to do. Why you have a cost? Get clear. X you have a nodes, number of nodes. You draw this that you are. Okay, I'm gonna keep this one. For the side. We show this one. Okay, then he drew this one. He got this one. Y hat B naught plus B1 X like that. So he went to the 68 node. 68. He has a true value here. He has an estimated value here. Let's say the true value and estimated value. True value 52,388. Its predicted value is below. Okay, that should be below this time. 68 means below. Okay. So see, it's the predicted value. So predicted value. So this one, I'm talking about this one. Okay. This is his Y value. This is the cost, which is Y. That's called the true cost. True cost, which is check that it is 52,388. 52,388. I'm going to go to here, y hat, that called the estimated cost. Estimated cost. That's a virtual cost. Virtual, which is y hat. Y hat is how much? They have given by this after running regression, they got 68,805. 68,805. So there's a gap between these two. So in addition to that one, do you know this y hat for all everybody? Okay, here, based on that given x, you can before given x will determine this value. Okay, so that's why we have given the equation of this one. Then when you plug in the 68 over here, v0 value, v1 value, that will calculate 68,805. But your true value is 52,388. This is 68,805. Then on the other hand, b0 and b1, do we know b0 and b1? Yes, where are they? There you go. See, 16,594. See, intercept. Look at that. See, intercept means b0. I'm gonna write here cost. I'm gonna say estimated cost again for everything, not for the given number of nodes. As an equation, estimated cost, which is y hat. I'm gonna write b0. b0 has been given 16,594 plus 650 b1 0.117. I'm going to keep it in decimal places times nodes. Every time you're going to plug in the number of nodes, that will give you the value for your y hat. That's the y hat value you're going to see on this table. See, this table. See, when you have a nodes, next node would be 52. For a given 52 nodes, estimated value. True value has been given. See, true value has been given. True value has been given. See, okay. Let's say a few of them. See, true value 51,761. 51,761. When you plug in this one into this formula for the number of nodes, how many nodes you have? You have how many nodes? See, 52 nodes. For 52 nodes, your estimated value is this much. So does with that. So do with all the number of nodes for the 14 entries. See, those are for the 14 entries. True value, true cost, estimated cost. As I said earlier, then they were looking for two types of estimates. Point estimate. You have this guy. With the aid of this one, they built up two things. With the aid of that estimated values, they built up two things for a given nodes. What are for a given nodes? Okay, for a given nodes, because one is what? Average cost. The other one, estimated cost, regular cost. What are you looking for there? You're going to looking for their confidence interval for this guy and confidence interval for this guy. They both are done through what? Estimated cost with this one. You need the average cost, you need the cost. Those are the things that I have written over here. This is the average cost interval. This is the individual cost interval. See, it is related to this one. You're going to say some people interested in average interval. You don't have average here, but you have an average interval here. See, average interval. What's the base estimate for the average? 68,805. Instead of that one, you say, no, I don't need the average. I give me the estimate for the cost. Still the same thing. That's what I'm trying to say. For given number of nodes, 68 nodes, is the average cost or the cost point estimate would be the same. That's why in order to distinguish these two, you go to the interval. Interval is the only place that you can see two different intervals for both cases. Otherwise, average estimate, average cost estimate or point, individual cost estimate always 60,000. It doesn't say, it doesn't, you cannot get more information out of it. Because they're already embedded both inside that one. We have only one estimate, one predicted value, 60,805. What is this? They are 60,805. Would that be average or individual one? You say the both will represent this, and then say how could they gonna differentiate? Differentiate through this interval. You give the interval and say, hey, I still can give that something that different. Okay, see, intervals are different. I want to give that something different to give you confidence interval for the average cost and confidence interval for the individual cost. Okay. That will differentiate. See, look at the upper bound, lower bound. Sorry, lower bound, upper bound, lower bound, upper bound. And this has been done for pretty much all the nodes. Calculate. This is the residual means this one. This is nothing but the gap between these two. Look at, if you take the difference between these two, you normally subtract y minus y hat. Okay, y minus y hat is nothing but the error. Error is how much? Negative. If you differentiate negative 8,470, that's the one you're going to see here. See? That's the residual. The gap between the y and y hat. That's a different story. But I'm trying to say that you are interested in the content, interested in knowing that the cost or the average cost or the individual cost. Then for a given 40 nodes, okay, you can talk about both, but you cannot give the same number for both. They're not happy. Then you say, hey, I'll give the intervals. And this can be in this range. If it is the average cost, it's going to be range of 50,545 to and $66,065. If it is individual cost, if you're interested in, it's going to go from 50,047 to 71,567. So out of these two, he might be thinking which one he gonna go with. He's gonna jump into the average because it's a shorter interval. See, 55 to 66. This one, see, 50 to 71. The very long range. Long range, no good. They're gonna narrow down. See, shorter the better, like that. Then while they are increasing their nodes, they can get all the information. All information here. All information here. So that's why in order to get those, I used this code. I don't do anything by hand. Look at the theory behind that one. The formula behind that one. The process, formula called the process. Process behind that one, very rigorous. Very heavy. You don't need that one because you are not doing mathematical statistics. Very heavy, heavy, very heavy. You don't need that. That's why we are learning programming. But you should know how to interpret at least the output. It's a key part. They were in the other one, you saw that already in the other. This one to all heavy formula. See, very heavy. You don't need that. You don't need that. It's already covered everything. We have to go to the SAS output. You nicely interpret, but you should have some skills and capabilities that explain very clear cut. That's the part they were expecting. The layman, the boss, the society expecting that one. So this is for the B. Then in addition to the B, okay, the confidence interval for B. Let's go ahead and see if there's a confidence interval for B. Yes, see? You give the B node and it's confidence interval. You give B1, it's confidence interval. Rather than you say that you have that cost, when there are no ports, still there's a cost. See, they're not using any cost, any ports, but there's a cost some. See, some cost being already added. See, in the very beginning, 16,000. See, 160, 16,594. That one. See. But you, rather than giving that one, you can give like a range. You say it's going to be 10,739 to 22,480. Still, you give an estimate to the people. You are the one who's going to give estimate and say, hey, it's going to be between this and that. and you are so confident. How much confident? 95 confidence. This is going to be like that, and your company not going to lose any money. See, because you have 95 confidence. And on the other hand, you say, what's my marginal cost? Marginal cost means like if you're going to increase the one unit, one number, one port, you're going to add it to this one. In order to add an extra port for this system, communication system, how much is going to cost? $650. It's a marginal. Rather than give the marginal, just simply marginal, you say, I give the range. It's going to be $504 and 38 cents to 795 to 97 cents. Like that, you can tell very confidently. I'm 95% confident this price is going to be based on that one, completely based on your data. This guy, okay, based on this data. Whoever bring the data to you, if you're not gonna, you can go and collect the data too. Or the company gonna that communication system or that telephone company or whoever that they're interested in, they're gonna give that its data and say analyze and tell that how we can make our company make profitable at the end of the day. In order to do that one, you have to analyze. It's a primary stage. That's a window. Their confidence in how do you get that one? CLV, CLM, CLI. So then what is this one? This one, okay, we can talk about this one based on that when the necessity comes, okay? What I'm gonna do, I'm gonna jump into chapter 4. In a chapter 4, look at chapter 4, this one we already, okay? Chapter 4, let's get that the data set that they have. Chapter 4 data set, I can get that one. Then let's open that PowerPoint a little bit and then move on to the homework at the same time, okay? I'm going to do both at the same time, homework, midterm, and 3 of them parallel. Okay, we do the same thing that we have talked about that one already. Chapter 3, we don't need that one. Chapter 3, we don't need that one. Okay, here. Multiple regression. We mentioned about that one. We talk about that one. Okay, we already talked about that one. You see, let's go to the example. Straight example that what we have already done that one, but we are supposed to cover only 1 through 3 last time, but we covered all the way up to that this one too. I mentioned this one. Look at the N number of pairs, sales territories, Y sales in each territory, advertising, amount of bonuses paid to salesperson in this Medico 4 data set. It's already, you can get that one too if you go to this data set, Medico 4. You can open and then get that data set. I'm gonna get that data set from my, here it's easy. I'm gonna open here, Medico 4. Okay, it's the data set. So you have a sales, say advertising, bonuses, market share, competitor. So instead of by checking that how the sales can affected by only the advertising, they have added the bonuses, market share, and the competition. More variables being added now. 1, 2, 3, 4 variables. This is the Y variable. This is Y, sales. Sales been discussed. Okay, sales been discussed. It's available here already. Okay, Medico 4. So see, they say out of all these, just take only X1 and X2 only 2. They want to put to the 2 only. Y is your sales. This is sales. Advertising is X1. Bonus is X2. Other 2 we're gonna just neglect for time being. Okay. So sales, the $1,000 in each territory. Advertising, $100 in territory. See, amount of bonuses paid to salesperson in the territory, and see whether you can increase the sale. How it's gonna affect to the sales. Whether advertising playing any heavy role to that explain the variation in sales. That's the one we got that one. I have that data. what happened here? Okay, I'm gonna get go to this one, data out. Okay, look at what I did. Okay, I'm gonna go to lib. Okay, okay, then that's my data. Medical 4, see, it's already there. Medical 4. Look at. I'm gonna do the scatter plot between advertising and sales. Okay, advertising and sales, only two. Sales versus advertising. You can do that. Sales versus advertising. See, look at. I neglected going through this route. See, look at what I did. I name. Look at the go to the in the chapter 3. How I did here in chapter 3 and yes, my chapter 3, chapter 3, chapter 3. Okay, here. Look at. I wrote all these. You don't need. I call this data out straight. And then I go and then call that one. Okay, that's what I'm doing here. See? I go to, this is my directory. See, this is my directory. Go to the directory. My directory has Medicope 4. Medicope 4. It's not CSV. That's the key part. Okay, this is what I'm trying to say. I'll show you. Look at this one. Okay, this is my, I'll show you that. Okay, I'm gonna go to this is my I. Okay, this is I go to NR 620. Okay, see NR 620. Okay, July. Oh, I'm gonna make this on October. October. It's the same thing. October 2021. Okay. Then I have October. I go that one. I go that one. Then I go to data. I'm gonna that folder. See this folder data. I open it. When you open, you can see my data are in CSV as well as in SAS format, both format. See, see, Medicope 4. See, it's in SAS format. See, SAS data set. It's a CSV data set. I'm not going to use the CSV data set. I'm going to use the SAS data set. So that means that if you want over there, what I'm going to do, I'm going to open this one. Okay, I'm going to open this one. I'm going to add, pull this one and then drag this one and put it this one over there. See? Let me see. Where is that? See? Medicope 4. If you open this one, yeah, see, go to this one, download. See? It's opening SAS because SAS already installed. So because of that reason, so I have Medicope, one in the Excel sheet, the other one in that SAS format, this one is the CSV format. Okay, so you have both here. So that's why I wrote like this. I don't have to see. I'm showing you that another way of doing that. I go to that one. See, I'm not going to use this format. See, that's why I hide that comment out. This one. If you want, you can use this one too, but you can use like this way. Still, it can get done. See, now data out. I have a Medicope data. Look at when I go inside. Even though I collect imported data from this one, it will be converted into SAS data set. Okay, remember they were not CSV any longer when they were here on the SAS platform. The very moment they've been imported from the CSV format, they become the SAS format. So they were here already in SAS format. Rather than go and call that one, I went to my personal folder, which is my library, which is my form, the directory, and I imported that data and then straight working with that one too. That's what I'm trying to say. Okay. So here that we do different way that one. Okay. So another way, see, You can say that go to Medicope, I can call that one Medi. Another way of doing that one. Without, you're not gonna make like a library. Another way to show you that how to get this done. I don't make a library. I just simply go and say, hey, go to this data and call the CSV data, get them and call them a Medi4. Okay, Medi4. See, look at what's gonna happen. If I run this one, the same thing. I'm talking about the importing data. Okay, they're gonna go to. Still, I have that one. Where are they gonna be? Where are they? It's gonna go to the some directory called work. It's gonna go to the work library. If you not gonna mention the name of the library, it's gonna go to this library. They create work library. See, I didn't give a name for the library. I didn't say same like here. This one is a different case. This one means like I'm gonna get the SAS data into this one. It's a different thing. This is the CSV data, and I'm gonna put this into my directory, data out directory. Here, what I'm trying to say that you don't even need the library. You don't need the directory. You call to get this one and say, hey, give me the name Medi. I like to not to go with the Medicop. You gave a name Medi4. See, Medi4. We are doing this one in different ways. Now I'm gonna draw the see with the Medi4 that scatter plot, the advertisement, axis advertisement, SG plot. Same thing, see X and Y being given. You can get that one. See, so many different ways. See, another way to draw this one. SG scatter. Look at what I do. SG plot becomes scatter. Now scatter put here and plot be put here. I see. I swap. Can you do like that? Yes. Can I draw the scatter plot like that? Yes. Sales versus advertising. But look at the format. Sales times advertising. See, if you put the plot here, you put sales times advertising. If you, but it should be SG scatter. SG scatter plot. Do like that. SG plot scatter. Same thing. See, then later on bonus. Excuse me, I'm gonna do the bonus for the bonus. See both ways. Okay, sales versus bonus, one at a time. Sales versus bonus. The higher the bonus, higher the sales. You can see the pattern. You know, kind of like a pattern. See, increasing pattern. Here, even that advertising. If you go to advertising, these methods. See, higher the advertising. See, the more money you're gonna spend for the advertising, more sales you're gonna have. See, that means sales advertising have a very heavy impact. That's why they were spending millions and billions and millions for these advertisements. The advertisements were in a heavy role. Heavy role. So we do that one sales versus advertising. This one sales versus bonus. Okay. Then the other way, the same thing being done in a different way. The more bonuses you give to that, the employees are being given, salespeople being given, that they're gonna do more sales. Kind of like, it's not consistent, but there's like a not highly correlated, but see, they were like scattered all over the place. But sometimes you can get some kind of that model to explain these variations. Okay, maybe straight line, maybe something else. Now what? Now you need a correlation among all these. I'm going to go to core. Medi4, variables are sales, advertising, bonus, all these put together. See? They will give you that separate averages, standard deviation. Their sum, their minimum value, their maximum value, how they correlate. Sales and advertising, see, highly correlated, 0.9. And bonus, not that much. As I said earlier, see, it's like a 0.5. That means almost no relationship that much. See? That this is going to be repeated here. And advertising, no, advertising means that the same thing. You always get 1. And 4, advertising to bonus is nothing. It's neglect. There's no relationship between advertising to bonus. Okay, it's not important. You know, that's the thing. Even though you have the variables, you're not going to check that all that relationship between all the variables. You have to be careful. What is your response? Response being explained by advertising, sales, advertising. Sorry, sales being explained by, I'm sorry, sales being explained by advertising and bonus, this way or that way. It's a sales versus advertising 0.9, which is very highly positively correlated. That means the higher the value of that, the more value you're going to pump for that advertisement, the more sales you can have. So that's a good observation. You can recommend this observation to your boss, the layman, and explain. And here, 0.5. Can remember, it's 0.5 slightly correlated. If you can remember that the range, and if it is between a negative 0.33 to positive 0.33, it's going to be definitely no correlation. But 0.7 to 0.33, 0.7 to 0.33, this is 0.56, 58, 57, sorry. 0.57 slightly correlated. It's not that much important. Bonuses are not, even though you give the bonuses, they're not going to increase the sales. So it's a waste. If they are trying to, boss was thinking like that, hey, I'm going to increase the bonuses and that way they're going to do the more sales. No, it doesn't work like that way. That's why you have to come to the optimal decision to come to that one, and they're going to focus only on the advertisement at the end of the day, and all the money they're supposed to be given for the asset like a bonus being the funnel or pump into the advertisement. That's what they do at the end of the day. In order to do that one, they're going to do this analysis. That's your job. You've been hired over there. And then those people, you are in a different department, the sales people in a different department. So based on that one, your recommendation very important. You have to interpret and explain to them. But remember, tell them that it's based on the given data set. SG plot, see, scatter plot. We do that, see, sales versus bonus. We did that one. See, correlation. Another way to get the correlation using the PRINCOM. PRINCOM means a principal component. Same thing, principal component analysis. We're going to do principal component analysis down the road. You see, you're going to decide how many variables will be important down the road, but it's not what I'm focusing on. I'm focusing on correlation. You got the correlation again. See, you get the correlation again, same thing that you got from the other code. Then we are really interested in this one. Now, I really, rather than do, see, sales versus bonus or sales versus advertising, see, you saw that same thing. We saw these results. I need the three-dimensional one. I want sales being drawn, advertising and bonus at the same time. How could you gonna do that one? We can do like this way, see? We can do like this. You go to G3D, see, Medico, scatter plot, advertising and bonus gonna be on X. This is on X-axis, X1 and X2. This is Y, sales. If you run this one, you're gonna get a three-dimensional figure, see? Advertising, bonus. That's three-dimensional. Okay. So we can draw that one by using this G3D. And again, now you're going to run the regression. See, regression between what and what? See, multiple regression. Y, X1, X2. I need the confidence interval for V1. Look at what's going to happen. Okay. Now, this is V0, V1, V2. What that means? If I write this equation, sorry. See, sorry, here, see, it's the equation, see. It's the same value we have, see, negative B0, B1 times advertising, B2 times bonus, this B2, okay. Those are the values we can see, B0, B1, B, this one. How do you get that one? Because we're gonna write the simple, multiple linear, still linear regression, multiple linear regression, okay. I'm gonna write that one here. Oh. See, multiple linear regression. We have sales estimate. Oh, I'm sorry, it's not connected. This one, chapter 4. Multiple linear regression and sales estimate. Okay, sales estimate equals B0 plus B1 times advertising, B1 times advertising plus B2 times bonus. See, bonus. So B0, you can see easily B0. See, you see B0. See, B0. See, B0. See, 106. I'm sorry, not that one. Here, -5, negative 516. Talking about this one, okay, -516 and 44 cents. Oh, that if it has been multiplied by 100 or 1000, I think should be multiplied 1000. You can, but I'm going to keep this one for my convenience of decimal places. B1 2.47 times advertising plus the other one 1.86 times bonus. That's a sales estimate. There are confidence interval being given because we already called them to give me CLB. We told them to give me interval. See, we were telling them to see, CLB. I need the CLB only for time being. I need the CLM and CLI. We are not focusing on that one for time being. So see, I got those. So these are the each values that the p values. See, you can run separately. Whether this advertising is plain, whether advertising is important in explaining the sales. Can you check that one? Yes, go p value. Reject H0. What is your H0? Advertising not important. Then if you reject H0, means advertising is important. Bonus. See, p value. Go to p value. See, 0.01, 0.01 less than 0.05. Still you can reject. Okay. Or you can see, I'm going to show you another way to check that one at this stage, for the important. Or overall you can see. See, it's called the overall test. Then overall, for both, you're going to put into the together and then see whether there's any important. Okay. So let's related to this one, I'm going to do individual testing. See, you can do individual test. Individual test. Then you can see whether advertising going to be playing a role. That means your H0 beta 1 equals 0. Beta 1, okay, versus HA beta 1 not equals 0. That's it. Then you're going to say since p value, let's go and check its p value. That's it. P value. Since it's p value, advertising related to this and see it's B0, B1. Okay, B0 not important. Okay. Very small, very small. Since p value, not the t value. Okay, you don't have to worry about t value. The p value is very small. We reject H0 and infer that advertising is playing a role or whatever explaining no role in explaining the variation in sales. any way you want. You can write in your own way. It says, that's it. That's all you got to do. Simply you write that and you go to advertising. The similar fashion you do for the bonus. Let's go to the bonus. Then do the same thing for the bonus, where the bonus is playing a role. That means you set up this one. You're going to write this hypothesis, you write, tell to somebody. That's the proper way of doing. You're going to say beta 2 equals 0 versus its counterpart beta 2 not equals 0. See here, second one again. See, you can say nicely here, since p value which is 0.01, I'm going to get 0.01. Okay, 0.01, no 0.02, sorry, 0.02, round to 2 decimal places. 0.2 is less than level of significance. Level of significance. Significance means alpha, which is 0.05. We still reject H0 and infer bonus also important in explaining the variation of sales. But how important, we don't talk about that one. That's the only thing we can infer. See, those are individual testing. You can individually check and see with this every component, every variable playing a heavy role or not. Because in addition to these two, there are another two in our data set. We didn't add those two yet. We were contemplating whether this is going to be added or not, or we were trying to play one at a time. First one we add, play and see, and then see that when you add another one, how it's going to work. And the market share, the share price, the market share, the market value, the share price is going to affect to that sales or competitors. See, there has been given this one. See, those are going to affect that, and these will be added later. And later on added, and later on say they're not, looks like they're not playing any heavy role. I'm going to take it out. Yes, when you take out, that's called data mining. You take out. So you don't go to that, they're taken out yet. We simply get the model and built up some few things. And the next one, instead of that one, I can talk about the overall test. Okay, these are individual tests. I did the individual test for the advertising and bonus. I can put both together and then run. See, individual test. These are individual tests. See, individual test. Instead of that one, I can talk about the overall test. Overall test. What that means? Instead of going one by one, I'm going to say simply, they both are not playing any heavy role. Both are 0 versus, you're going to say HA, at least one of them. Not because at least. I don't know which one. We don't know which one. How do you do that? For do that one, you go to the analysis of variance table. See, this table. This is called the analysis of variance table. See, this table. Then you're going to say from ANOVA table, see, from ANOVA table, you're going to say here, from ANOVA, it's analysis of variance table. For table, since, again, p value. Look at the p value. You say p value, another p value. See, small. P value is small. Very small. We reject H0. H0 and infer that at least one of the variables, bonus, I'm sorry, advertising, bonus, one of the variables is important in explaining the variation of sales. Explaining the variation of sales. See, you can tell it. Sales. That's the overall test. You can run the overall test. See, you don't know which one. In order to do that one, there are more tests. These were added later on. Primary stage, we don't going to talk about everything. It's very expensive. On the other hand, there's a very important part you have here. These are very, very important, whether your model is good or not. R squared. R squared is playing a key role. R squared is nothing but, you can remember, this is the error carried by that empty model. And this model regression model explain so much of error. See, this is sum of squared model regression. This is sum of squared error. And this much of 106, 77, 97 has been explained. There's been a lot of been explained. 84% of the data, sorry, not the data, error being carried from unexplained error, carried from that empty model, being explained by your regression model, suggested regression model. My suggested regression model, which include 2 variables only, is in a good shape. But still there's a leftover. But how could you gonna calculate this one? You don't calculate, but I gave the idea. You're gonna divide this by that. See, 106, 7797 divided by this one is same as this one. That means R squared. R squared say that it's called the goodness of fit. See, then you can go to the goodness of fit. Goodness of fit. You got a goodness of fit. How fit that data into that particular model. That's what called the goodness of fit. Its counterpart called the lack of fit. We're going to come to lack of fit to tackle the worst scenario later on, but for time being, goodness of fit can be tackled by R squared. R squared. Look at R squared. R squared is nothing but PRE. You can remember. PRE. PRE means proportional reduction in error. How much error being reduced by our model? See, proportional reduction error. The percentage of error reduced by our model. Or that's the same thing. Percentage of variation or error explained by our model, reduced by our model or explained by our model, right? Our regression model. How do you get that? Sum of squared regression divided by sum of squared total. In this case, sum of squared regression is how much? It's already there. We don't calculate. I'm just showing you. SSR is 106. 106. Everything comes from the ANOVA table. 106, 77, 97 over 1224, 89, 74 times 100%. That's how much? They say 0.85. I'm sorry, I'm going to say 85%. 85.49%. R squared. See, that means good. It's a good. It's around like a more than 80% being explained. That's a good model. This is a good model. And then you are suspecting, can I add another variable and see that at least I can increase this R squared goodness of it? Yes. You can give a try and then you can add the market share and see how it's going to work. So this is a process. So you do all the tests and then you're going to go ahead and give the report to your boss or explain to the layman based on the scenario, based on the situation. Okay. Then in addition to that one, there's another key role playing this guy. Look at it. He's a little bit lower than this one. What's going to happen? when you're going to add the variables, even if they're not playing a heavy role, your R squared going to go up. R squared going to go up. You think, oh, this is a very good model, but you saw that one at a certain point by drawing the scatter plot, looking at the correlation coefficients between that bonus and sales you saw in the beginning. At this stage, see, at this stage, when we were talking about the correlation, at this stage, you saw the sales is not that much. So I'm sorry, the bonuses are not playing that much. See, it's 56, not so tightly related to, not strongly related to the sales. It seems like it's not playing that much of a good role. There's a way that we can weed out. There's a high probability we can weed out, but we are looking for some reason for that to be weeded out, because that can be, we can explain through this one, through sorry, this one, okay, here. This one, R square. See, R square here. It's lower. What that means? They say that even if that some variables are not explaining that variation of the sales, your R square gonna go up, inflated. That inflation no good. You have to control that. In order to control, we're gonna adjust R square. How do you adjust the R square? Look at how could we gonna adjust the R square. You can adjust R square like this way. Now you come to the under the goodness of it. See, you have R square. One. You have R square. You have R squared adjusted. Adjusted. That's the one we're gonna write R squared edged. See, like that. Okay. What is this? We know that R squared is nothing but sum of squared regression divided by sum of squared total. But we know that sum of squared regression, we can write sum of squared total minus sum of squared error. See, if you're going to subtract the error from the SST, that's same as this one, because we know the relationship. See, SST equals SSR plus SSC. So SSR is nothing but SST minus SSC. SSR. SI, I replace SSR with SST over SST and SST. Then SST divided by SST minus SSE divided by SST. This is 1, they get cancelled out. This one is SSE minus SST. That's the same thing. R square you can write in 2 ways. See, either like this way or like this way. Now what I'm going to do? Therefore, R squared adjusted means I'm going to adjust this one like this. I'm going to divide this guy by its own degrees of freedom. Error degrees of freedom. In a similar fashion, sum of squared total I'm going to divide by its own degrees of freedom. Now we know if you divide sum of squared error by its degrees of freedom, it's nothing but mean squared error. See this part. So it's nothing but MSC. See, mean squared error divided by mean squared total. That's how they calculate that as a percentage. In this particular example, look at 1 minus mean squared error. That's how much? 82. 35.29, 179 divided by, I don't have SST. I can get the SST by MST. I don't have MST. I can get MST by this way. SST 124,8974 divided by its degrees of freedom. They say, and times, this whole thing times 100% is, we don't calculate. It's being calculated for us They say 84% 18 R square adjusted. Actually, we looking into the R square adjusted at the end of it. See? Is the one still good? R square adjusted is the one. Why we use the R square adjusted? To prevent the inflation. See, sorry, not the inflation. They're gonna that see. Sorry, yeah, kind of like inflation that inflated this the value, even if some regressive variable, even if some variables, explanatory variable, independent variable, or X variable not gonna explain the variation of sales, still we see this one, see, even see, even if some X or independent regressor, sometimes called regressor, or explanatory variables in our case advertising, advent bonus, the R squared is inflated. To prevent that, R squared has been adjusted and expressed as R squared adjusted, H, which is in this case 84.18%. So that's another way to goodness of fit check. Okay. Those are root mean squared is nothing, but you know that root mean squared. There's another one too. Another goodness of fit. See, root mean squared error. See, root mean squared errorless. See, see, see. I'm gonna write here another one. We hire the value of R squared or R squared adjusted. The data the model is around greater than 80%. 80%. That's one good. Okay. And third one, we can look into root mean squared E. This means root mean squared error is nothing but you go to the mean squared error, take the square root of that one. You have a mean squared error already given. See, mean squared error. See, 8 to 35. 8 to 35. 35.29179. That's the value they have given approximately. Okay, I'm gonna put that legally know that tilde that has been given 90.775. See, the lower the value of see, the lower the value of RMSC, the far better the like that. Okay, we're gonna do this one in more detail down the road in a selection procedures, but for time being, to explain your model, especially multiple regression model. Okay, this one very important. Very important. So you know these values, you know p-value, I explain everything, their confidence interval. Look at what's gonna happen. I'm gonna run this one, same thing, okay? Same thing. I'm gonna run same thing. Look at the code. Now instead of using the reg, I'm gonna run sales, advertising, bonus, my model. I'm gonna use CLB. They call the CLB here. Here they call They've been called what the confidence level for parameters. So B0 and B1 called parameters. PARM is parameters. Look at. Guess what's going to happen? See, look the same. Look the same. You can remember R squared and all kind of stuff. Do you see the R squared? Yeah, see, 85%. They don't have R squared adjusted. Another one, root mean squared. See, 90% something, 75. We got the same thing. These values the same thing, ANOVA table. See, confidence interval for the parameters, they were the same. But make sure you put the code CLPARM for if you use the GLM. When you use the GLM, the results very scary. See? Oh my God. What is this? This one, okay. This one same as the earlier one. This one same as the earlier one. This part same as the earlier one. This one too. But extra part is this one. Sorry. This part is an extra part. See, these two tables, the middle two tables. I'm talking about the third one, 1, 2, third one and the fourth one. Those third and fourth tables being added, and they were now called the type 1 SS. They were not SS anymore. Here SS, here called the type 1 SS. What is this? Here called the type 3 SS. There. Now you have to explain that by accident if you run this one, you have to somebody say, hey, run the GLM and give me the result. GLM, see, I'm here. I ran this one. See, when I ran that one on my regression model, I got the information, I explained everything. I checked for the goodness of it. I did the individual test, I did the overall test, I did the goodness of it. Under that one, I talk about the pre or R squared, then I talk about the R squared adjusted, then I talk about the MSR. See, this one, very easy. You don't have that kind of that SS type 1, type 2 nonsense. You don't have, very plain. Forget about this graph. See? But when you run that GLM, general linear model, GLM, that means generalized case, most general case, GLM, general linear models. See? In addition to get these three, you're gonna get another two. See, another two. What that means? What that means? This means something like this. Okay, I'm going to write here very clearly for you to get a clear idea. Okay, right here, I'm going to say, start the sum from decomposition. Decomposition of sum of square regression, SSR. Okay, SSR. See, regression, sum of squared, or sum of squared regression, or sum of squared regression. I told you can write it either way, which is SSR. You can read from left to right to right to left. Okay, can be partition into pieces in any order. Okay, in any order. That's what's going to happen. I'm going to explain related to what you see here. Okay, that's what I'm trying to do. Okay, first one is type 1 error. Okay, type 1 decomposition, type 1 is related to this one. Okay, this table. See, look at this table. You have a 106779731. Looks like it has been decomposed, this guy, into two pieces. two pieces here. Okay. See? It doesn't talk about, this doesn't talk about the bonus or advertising or bonus. That has been, but how this been decomposed in a which manner? We have to explain very clearly which manner this has been exposed or decomposed. This is the way it has been exposed. Okay. I'm gonna say sum of squared regression. If you calculate with the aid of that advertising and bonus, okay, see, they think it is same as sum of squared regression only by advertising plus sum of squared regression. You're gonna do this one given that you are advertising already in the system with the bonus. That's what it means. You can split like that. You can split like that. See, you're gonna run the regression one like a simple regression that can be added to regression. This kind of a regression added that bonus given that you already have advertising in your model. Yes, you already have an advertising in the model. Now you're gonna add the second one. If you have a third one, you keep going. Third one, let's say market share, given that bonus and advertising already in the system, then you're gonna write market share, this line, advertising, comma, bonus. But now the question is, what this means? What this means? This means, you know, this is nothing but when you run the regression with the aid of advertising only, how do you, when you get the sum of square regression, okay, that regression, you can run that one. I can write the code here, but I'm talking about, see, in order to support that one, that's the one I'm gonna start writing here in order to write that, okay? Advertising only, see, advertising only. Second one, advertising and bonus. I'm gonna come to that one later. You can run that one, but from that one, what I can get it from that one. How they calculate this one? This is okay. How about this one? They say where, I'm gonna write here very clear, where sum of square regression of regression you calculate when the bonus given this one means advertising means nothing but, okay, sum of square regression you calculate with the aid of advertising and bonus both minus sum of square regression you calculate with the aid of the one here advertising only. That's how they calculate. This tells us something very clearly. They tell in order to calculate this guy, you need, see, multiple regression running, multiple regression as well as simple linear regression running, and their difference. This one is there. Or same thing I can write this way. Or it's same as sum of squared error of the advertising minus sum of squared error of advertising comma bonus. Same thing. That means I have to run regression with these two and this one separately. That's what I'm trying to do over here. See, that's what I'm trying to. This one I already ran, but for your convenience, I'm going to write again. Okay, because I'm using rate for you to see clearly. I don't go to that GLM again when I run. Okay, okay. When I run this one, I'm going to run these two together. Okay, both together. One with the sales versus advertising, this is the other one, sales versus advertising and bonus, both with the aid of reg. Okay, I'm gonna run. I go to the ANOVA table. That's all I'm gonna do. Mainly go to ANOVA table in both cases. Okay, let's go to the advertising. What is this? Sales being explained by model one. Sales being explained by advertising and bonus. See, this one states that this is a table for the when you have the two variables, this ANOVA table when you have one variable. See, then according to this formula, you need the SSR for both. Okay, SSR for both is how much? SSR for both is second one. Okay, sum of squared regression when you have a both. Okay, advertising and bonus is 106 7797. I'm gonna write here 106 7797 minus you're gonna subtract when you run the regression sales on sales versus that advertising only 101 okay 2408. If you subtract those two like that, I'm talking about, I'm plugging into this formula. Okay, the top one, SSR of the single one, no, double one minus SSR of the single one. Subtract, they say you get what? This guy. Sorry. This one. This one. Where is this one? This one is the one that you got earlier from running this one. When you run this one, you can remember when I used the regression, I had an issue. That's the one I'm trying to explain. This one is 106, 106, this one. This is a add. Second one is this one. This one is nothing but the difference between these two. That is same as this one. That's what I'm trying to say. I'm sorry. That's the same thing. This one. This one. This is when you run the with the advertising only. That's the first one. This one, this table, this one is nothing but this one. This one. This one is the second one. Okay. Talking about this guy. How do you get that guy? By subtracting this one. It's gonna be what? 55, 389, 370. If you subtract this one, see, at least that you're gonna get me 10, 6 minus 1, 5, see, 5, 5, 3, 8, 9. If you subtract this one correctly, subtract this one, 106, 106, 977, 106, 106, 7797 minus 101, 2408, 55, 389. See, forget about the decimal. 55, 389. 389. See, you got that. See, that's what I'm trying to say. And on the other hand, if you add those two, if you add these two, that will same as that sum of squared regression you run by that one from this table, not this table, not this table. Here, if you add these two, that means if you add these two is same as this one. That's what they say. Now you're gonna add this one, SSR, that those two. See, now you add these two. See, SSR add plus this one. See, if you add those, okay. See, I'm gonna write it down this one more time. I'm interested in SSR, advertising, and bonus, which means is same as SSR advertising only plus SSR bonus given advertise. Okay, advertising SSR advertisement is we already found. See? Even on this formula here, see? SSR see? Advertising bonus is same as 106.77, 106.7797. See, see, plus see the gap. This one 55,389. 55,389. I'm gonna get what? Should come with this one 106. No, I'm sorry. I was at the wrong place. 101. See, this one is 101. See, 101. Okay, this one. I'm going to write very clearly. This one only is not the 101, 102. It's this one only is 101. Can you remember when it's been only run by that guy only? This one only. Advertising only regression. Single one. See, 101, 2408. Sorry, I wrote the wrong one. 101. It's not right. 101. 101. 24. 101. 2408. You add these two. 101. 101. 2408 plus 55 389, we get 106 106 106 7797. That's what I'm trying to say. When you run, I'm not talking about a single one, I'm talking about when I run the multiple regression, I have a serious issue. When I run this one with the GLM, I got this one. This one, see, I got that one. But I'm trying to say, if you add these two, they will add to this one. If you add these two, how do you calculate this one? Is the one that I showed you. But we don't do by hand. We don't do anything. Sorry, I clicked the wrong one. We don't do that one, anything by hand, okay? We don't do anything by hand. See, but what I'm trying to explain you over here, these two will add, they will add to this one. See, those are called the, see, single. This means not simple advertising only. This means not the bonus. You have to write this one bonus given advertising. That's what I'm trying to say. Bonus given advertising. See, bonus given advertising. If they add those two, they add to this one. That's called the type 1 error. See, see, they were add. See, they can add. They can add. When the type 3 not like that. Type 3 do the different way. Okay, I'm not gonna do this one over here, but this one is. I'm gonna write the format for you to see. Since I have already explained this one, these two add to this guy. But these three, they don't add to this one. Sorry, these three, these two, type 3, they don't add to that one. Sum of square model or sum of square regression. These two, sum of square regression being split again. See, this is sum of square regression in type 1. In the bottom line, sum of square regression has been split into two parts. Sum of square regression has been split into this one, advertising and bonus. Sum of square regression has been split into sum of square regression only with the advertising and sum of square regression with the bonus given advertising. This kind of a sum of square we're gonna call extra sum of square or hierarchical. See, hierarchical. Okay. Or we can say sequential sum of squares. Sum of squares. Because of that this is called condition. Okay, this is called given condition. Those are condition. Okay, sum of square we're gonna say sequential sum of square. Sequential sum. That means these two decompose into two parts. That's what they do in type 1. In type 1. Type 1. See, to support this one, if I say that, okay, I'm going to write the general case for you to see that general case. Let's say that you have that you have the regression model B0 plus B1 x1 plus B2 x2, okay, plus B3 x3. I'm going to go to 4 of them, okay, general case. I have. That means sum of squared regression of the x1, x2, x3, x4 is nothing but sum of regression x1 plus sum of regression x1 given x2 plus sum of squared regression x3 given x1 and x2 plus sum of squared regression x4 given x1, x2, x3. And where if you want sum of regression x3 given x1, x2, how do you get it? Sum of squared regression. Sum of squared regression of all of these x1, x2, x3 minus sum of squared regression of only the one in the denominator. A similar fashion you can do for all, but we don't do by hand. You have to get the idea. That's in type 1. This is type 1. Type 1. Those are called sequential. These are called the sequential sum of square. Sequential sum of square. The other one, type 1, you can see. And on the other hand, in type 3, if I write this one real quick, type 3, not the type 2. I'm gonna skip type 2. Type 3. Look at. So SSR. See. Those are whatever you see are like this: x1 given, x2, x3, x4. All these, not one at a time. Every time, everything has been taken into account. And x1, you say that I'm going to add the x1, given that x2, x3, x4 already in that data frame, my model, like that market share, advertising, the competitors. See. All this that you can say that, okay, I need to advertising here. You're going to say advertising. Yeah, you're going to add the advertising at the last minute and then say you already have added already. This is already done. Okay. This already done. That's why I say tell given. Okay. X2, like you can say X2 means bonus. You can say X3 means market share. You can say X4 means like a competitor. See, they were already in this one. And the other SSR, whatever you see, the other SSR is nothing but second one you're going to put, given that X1, X2, and X3 in the system already. Those are being that decomposition, but they don't add. You don't put the some plus sign. SSR X3, X1, X2, X4. And SSR X4 given that XS1, X2, and X3. See, that's the idea. Those are the one you're gonna see here. See, in type 2. In here, 2 cases. Okay. Let's say for your convenience, I'm gonna add another one to this one. Let's say that you MKT SHR. If I add to this one and run with this one, you can see clearly. See, type 1, see, this one is advertising. You can remember in type 1 how we wrote. This guy only. Later on, you're going to add the bonus given advertising. And this guy is what? Market share given advertising and bonus. Here what? Here you're going to say advertising given other two already in the system. This one is what? Bonus given that advertising and market share. And the market share, this third one is what? Sum of square regression of market share given advertising and bonus. These three add to this one. That's in type 1. Sorry. The type 1. These three. I'm sorry. I'm talking about this sum of square. 101, 24, 55, this one add to 107, this one. But here, no, they don't add. You don't add. But the way that how we write, SSR add only, SSR bonus given add, and third one, SSR market share given add and bonus both. Add and bonus both. Add and bonus both. See? Here how? SSR add given other all two already. You're going to add the advertising at the last minute. Anyway, you say market share, you can change it. Whoever at the last minute come to the top. Okay, that's what I want to say. Interchangeably, you can do it. Let's say for my advertising, I'm going to plan it to add at the end of the day. But at the same time, you're going to say add given these two. That's this value. This one is sum of square regression, bonus given, add and market share both. And this one. Add market share given add then bonus. Then if you want, you can add the comp. No, I think that one is comp. That comp, let's say that competition or T. I think comp or comp. Let me see. I want to see data set. Compete. PET. ELM. Okay. Okay. That means that you know how to read the two table now. That means what I'm trying to say. Okay. See this one. See full example. If you go to full example, that means your y hat is B0 plus B1 times advertising plus B2 times bonus plus B3 times market share, CHR plus B4 compete. Okay, like that. Then SS type 1. SS type 1 means first line, that means SSR add only. Second one, SSR, you're gonna say bonus, given that you have add on the data set, but they can be add. SSR, third one, you're gonna market share. Market share, you're gonna add and calculate the sum of square regression, given that advertising and bonus already in the system, both. Plus, this one plus, the last one is competition. You're going to add and see, given that already you have advertising, bonus, comma, and market share. That's type 1. Those are the one you're going to see here. Here, I'm talking about here. 1, 2, 3, 4. Those 4. When you add those 4 is nothing but SSR of full model. SSR of full model. The same as SSR of full model, add, bonus, market share, and competition. That's type 1. The type 2, you have go to SSR about the add, but you assume that you already have market share, bonus, market share, and compete already in the system. Then you're not gonna add SSR, you got a bonus, given that you have advertisement, market share, and competition already in the system. SSR, then you go to market share, one at a time, share, given that advertising, bonus, and competition. The last one, SSR, it's gonna go one at a time. Compete, advertising, bonus, and advertising, bonus, and market share. That's what that's what you see here. Those four you see here. You can explain one at a time. You add what's going to happen, then keep adding, and then you say, okay, you already have these three. Let's add the advertisement and you're going to start from here. The advertisement, market share, competition, and say bonus ad. What's going to happen? Advertisement, bonus, competition, and market share, given that they were already in this one. If you add a third one, the fourth one, see, when you add the market share, look at this one, see, some squared error. That means this guy is explaining very little. See, you can see, this is nothing. Competition is negligible. It doesn't explain too much. Some squared regression means the empty model carry that unexplained error should be explained by this model. They cannot do that one. The only one who can do that in large scale is the advertisement, as well as the bonus. So simply you can keep those two, and then these two can be weeded out. This one gonna go away for sure. Competition, you don't want to add to that one at the end of the day. In the beginning, for the sake of adding that one, you're gonna add, and then by adding, you simply go to this one and see, wow, man, I have 4 of them that this can explain everything. You can remember, even though you add the 2 in the beginning, you still have the 85%. Even though you have 4 added, still for 85%. That means they have nothing, no big impact on that one. That's the discussion you built up in this data analytics. In order to do that one, that's the part that in the machine learning, the machine gonna decide that one. At the end of the day, they weed them out, completely weed out, and then he come to this decision making under the supervised that machine learning. When it comes to the unsupervised, they're gonna make the clustering. They're gonna cluster and see that when they were planning to give if they were the lenders that before that they're going to give the loans, or the people trying to borrow money from the loans, then lenders going to check and see these people have how their history, whether they have paid and without defaults, their income category, their education category, their social status, though everything they're taken into account and before they're going to release that one. The machine been already programmed in such a way that he's going to cluster that one. That's called unsupervised. The supervised, you use the regression, okay? But the bottom line here, that get a rough idea what these will represent, that's it. Okay, you don't have to worry about heavy anything behind that one. Get a rough idea. That is so support that one, I did this one over here. For the support that the second one I did over here. Let's run this one. Let's see what you're gonna get. See, you know what is this? This is the regression plane. Regression plane. Regression plane. I'm focusing this guy. How do you draw this one? This is the regression plane, not the regression line. We talk about that. Regression plane, how do you draw? I do this one. Go to the, see, yeah. The graphics on, see, and then we go to RSC. See, response surface, RS, the response surface, it's called the response surface. Reg, data, plots, surface 3 dimension, lack of fit, okay, bonus, advertising, sales, this is the model, okay. This is how we're gonna draw the plane. regression plane. Okay, regression plane, regression plane, regression plane. Here, regression plane. See, regression plane. That means this is what I'm talking about. The way that they draw, anyway, that they have drawn this one. Let me see. Go to the results. Bonus here, advertising here. See, regression plane. So here you have sales. You have sales. This is Y. Here you have X1. Let's say that advertising. Here you have X2 bonus. This is in 3D. See now your data here. Okay, in three-dimensional plane. Then you're gonna have a plane. You're gonna go through that one. That's the fitted plane. Fitted hyper three-dimensional plane. Here you don't have to say hyper because three-dimensional, because it's a three, we have dimensional plane. How do you write that one? Y hat, nothing but B naught plus B1 advertising plus B2 bonus. If you only stick to that, so that's the equation. Equation of the this the response surface. I'm going to use that word. Okay, and another one here is response surface. RS. R is response surface. Three-dimensional surface. This is a response. You know that this is a response. Okay. Response has a surface now. Y has a response surface. Equation of the response surface. How do you write it? We can write the equation because you know V naught, you know V1, you know V2. But how to draw the surface is the one that we discussed. That's the code. When you run the regression, you know that you can get the V naught, V1 and then put it back. Okay. So this one we're gonna come later on. This one called the selection procedures. Okay, to this point. So that one, and then what we're gonna do, let's go ahead and pull out that our homework and have a look at it. And I'm gonna continue this discussion, keep going on that Wednesday and Thursday too. Okay, in that way you're in good shape by the time that we finish the Thursday evening. So I'm gonna go ahead and pull out a little bit the next homework assignment, homework, week 2, homework. Look at the homework had modified. Okay, I don't think you're gonna see this one. I think something is missing. I have a full scale that homework. What I'm gonna do, I can pull this out and then put it over there right now. Okay, I don't think you have this whole thing. Okay, you can read a little bit clearly first. You see, so homework. This problem uses data from 2 data sets. One is the Berkeley guidance study and a UN study on fertility rates from 193 countries. These data sets are available in doc sharing. Please, okay, the data.
We definitely don't have all of this.
All of them, yeah. I'm gonna go ahead and I'm gonna go ahead and put this one right away right now. Okay, I'm gonna go ahead and put this one right away. Okay, let's get that one. Let's put this one. Go to week 2. Go to week 2. Yeah, week 2, and then I can pull this out and see. Week 2 lecture, PowerPoint. Here's a week 2 practice, discussion, assignment, midterm like that. Okay, what I'm gonna do. Okay, I'm gonna say homework 2. Hold on. Before that, I have a system. There you go. It's already there. Week 2. See, no? Where is that? Did he go to the wrong place? Where's the homework 2? Week 2 discussion, midterm, week 2 assignment. This is called, oh, I'm sorry, you cannot see 2. Where is that one? Did he go to wrong place? Week 1, week 2. Discussion. No, looks like we do. Where did he go? Did he go to the week 1? This one. Week 1. Chapter 1, 3. Practice, discussion, assignment. Okay. Week 2. Did he go to week 3? No, I don't see. Where did this go?
You put it in the data section at the very bottom.
Very bottom. Oh, okay. Oh, yeah. There you go. Sorry. So let's get this one. Yeah, that's what I was wondering what happened. Thank you. Okay, then let's go to data. No, I need to get out of data. Go to week 3, week 3, week 2. Here. Did it go? No. Yeah, there you go. Week 2 assignment. Okay, good. Yeah. So that's I'm gonna get this one to make it a little bit larger. You can see on your side too. So the data from the Berkeley guidance study reside in Berkeley guidance study data file BGS girl. The Berkeley guidance study enrolled children born in Berkeley, California between January 1928 and June 1929, and then measured them periodically until the age 18. This is the people who did this experiment. The data we use include heights in centimeter. HT2, HT2, HT9, HT18 means weights in kilogram. W2 and this one, okay, we're gonna complete later on. Heights in centimeter, 3 types of heights: 298, 18, 29, 18. Leg circumference in centimeter, LG 298, and strength in kilogram, 298 at ages 2918, at ages 2918 respectively. 2 additional measures of the body types are also given. Body mass index, which is calculated as a BMI, weight divided by height divided by 100 squared. We have weight in kilograms divided by the square of the height in meters, a standard measure of obesity. Blah, 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 like that. Then they are given another type called the SAMA. SAMA type is that, you know, that one has been given based on that one. But in that our data set, when we go and open the data set, homework 2, BGL, that data set. Let's open that data set and see whether, I want to go ahead and see. Okay, let me see. Assignments, homework 2. This one, I'm going to open this one. Okay, I go to, it's easy what I'm going to do. Yeah, SAMA, see? Yeah, that one too, no? That one you have, see? W2, HT, 9, LG, but some are missing. I think this is a gender. 2, height, weight, see? Strength, I don't see at the age of 2. In the full data set, we have all of them. Height at the age of 2, weight at the age of 2, only, height and weight only. What happened to the LG2? I don't see LG2. The leg circumference or the strength, I don't see those two. They were missing. And then go to 9. Pretty much they have all these in 9, 4 of them. Height, weight, height, weight, height, leg circumference, and then strength at the age of 9. Yes, we have all these. Then go to the 18, at the age of 18, weight, height, LG and ST. We are missing when the age of two things. And the summer type, see, summer type is a taxonomy developed in the 1940s by the American psychologist William Herbert Sheldon to categorize the human physique according to the relative contribution of three fundamental elements, which is termed summer types, see, types, classified by him as a, see, ectomorphic, mesomorphic, and the endomorphic, and the blah blah like that. This has been taken. This one based on that. These three numbers. See, they measure this one. These are not important for our data. These have been done. So everything. See, done for that one. So this is a description for anybody to that to get a clear idea about what's going on. So generator scatterplot matrices are all continuous where group the variable by gender so that each paired observation has a gender associate label. Explain the relationship that you see. Generate two simple linear regression that predict WT18. The weight at 18. Two regression models you need. One regression model to predict the weight for the boys and the other predict the weight for girls. Interpret the results. Okay, let's see what they were trying to do over here. So let's go to this discussion. We're going to continue again in chapter 4, 5 like that. Okay. For time in homework 2. Okay, let's go. So I have that date. I'm going to go to October. And I usually in the Q1, same way. Data name is homework 2 BG Golf. BG all.csv and so the same date that submitted this change or not. Yeah, see, we don't have a 2 missing. Okay, strength and leg circumference. See, for the at the age of 2 are missing, but that's okay. Whatever based on that one, that means you don't have LG. See, LG and ST2, LG2 and ST2 we don't have, except for that one. We don't have one thing, summator type, and then what else? Let me see that we are missing. They say they put the BMIX. I don't think they have this one either. I'm talking about here the full data set. We don't have. They say that in addition to, see, blah blah blah, body mass index. I don't see that one either. Body mass index and summator type pretty much they go together. So I think they've been embedded within the same thing. See, at the blah blah blah, and the 2 additional measures of body type are also given. See, body type can be that given through, I think more elaboratively through the not the BMI, through that summator type. So it's already over there. It's so in me like that. Okay, doesn't matter. Now what are you gonna do? They need the what? Look at what we're gonna do. We need the scatter plot. Before we come to scatter plot, I'm gonna change this one. Okay, so let's go ahead and read this one. Let's say group the variable by gender, group them by gender, so that each paired observation has a gender associate label. See, you're gonna group them. How do you group them? How do you group them? See, you have, can you remember they on the data set for the gender, you have 0 and 1. See, numbers 0 and 1. See, the male and female. See, so which one is male, which one is female? How they have decided this one? Which one's gonna be? They go with the alphabetical order. The female being that given by the 0, I think here 0. No, 1. No, here they have given. I'm sorry that sometimes they take with the alphabetical order. They have given 0 for the male and female for that. It has been given, I think, in data set. Sorry. If not, they take by itself. But doesn't say clearly anywhere. Oh, here, I'm sorry. It's here. 0 males. 0 males and 1 females. Okay, coding gender has been given. So 0 males, it has been given. So what we're gonna do, we're gonna see 0 means male, 1 is female. Now we're gonna record, okay? Recording. What we're gonna record, see? Use if then logic to record males. See? Set. You get the set means like you're gonna get the data from here and set to that one back again. My data is in the data out. My data already in my this library, data out library with the name of Berkeley. See, this is my data. If I do any changes, I'm gonna put back to again. That's why I'm gonna say set it. Set means like a do get the data and do some kind of whatever the changes you wanna do it and put it back again. Okay, put it back again. So for the length, I keep the gender. See, my length for the gender. See, gender. See, can you remember here what we have in the data set? Here says sex. See, it's gonna be changed to gender. See? See? Now the gender. So the see, gender has that the length 12 that locations. When you have that sex equals 0, then the gender call male. Else, if they call the gender, I'm sorry, here sex is 1, then we call the female. Why they male? Female. Oh, and the else gender, keep like this. Else if sex, then gender. Oh no, this one, I'm sorry, this one is male too. No? Both male. This we run. Run this one first. I'm going to run all the way up to here. This is what I'm trying to say. See, now this one, I have a new one called gender. New variable called gender. I don't call that one 0 and 1 anymore. 0s are males, 1s are females. That's how I'm going to label. Oh, I'm sorry. That's what happened over there. Female, yeah. Female. Female. Yeah, see. See. So what I had was 0 and 1. 0 people are called the males. This one, see. They were labeled. I'm gonna call the gender like this. I'm gonna format first. I say I don't need the 0 and 1. I don't need 0 and 1. I'm gonna call that one male and female. Later on, I say I don't need the gender. Sorry, I don't need the sex. See, this is you put it back into the gender. Okay, you are formatting here for the gender up to here. When you format, see these are changing. But later on, you're gonna call to that sex one and then 0 wherever 0 that one. And now I call gender, not call the sex, call the gender. Even gender, they call the male. For sex 0 means gender male. See? Gender is like a string. Then if you put like in a sex, it's like a number. I change the name as well as their labels. That's what I'm trying to say. I change the name, I change the label. I format first and then run. See? Get that one and run. See? Yeah, because I know what you call that one now, gender. And I change the labels. Change the name, change the labels. Okay. Then see, I'm gonna use that if and else. See, if like this like this. If else, if this one, then gender like this. Else gender like this. Okay. That's how they say. Okay? Like that. So when I run, I got what the I'm sorry. I have to run this one too because he doesn't recognize this one. The whole thing to be run together. First format, gender. The sex has been formatted to gender, and their names labels been changed, 0 to male, 0 to 1, and this is the setup. Now I'm gonna say set to see. Then SG scatter plot. See HT2, HT2, yeah, W2T. I'm gonna get this one to here. And then they go to the height and weight, height and weight, height and weight at the okay. Height, weight, then HT9. I'm gonna get this one together. What? Anyway, yeah, it's not a big deal. HT9, WT9, W 10, doesn't matter, 18, AG9. Let circumference. ST9 and cut to that one. Easily that cut. Then go to HT height at age 18, weight at 18, LG at 18, and strength at 18, and some has been given by group 6, but it has been format, it has been given in gender, or you can put the gender, okay? It has been formatted by gender, given by group by 6, but 6 has been formatted to gender, okay? So you're gonna get the male and female. Otherwise, you get 0 and 1. Male and female. Male for the blue colored one, the female for this one. That's how you it like that. Think, look at this WT versus HT9, blah blah blah, everything over here. But we recorded format gender dot. See, to give like that by genders formatting. That's one. If you type in the exactly the way that we put, you can get the two of them. Okay. If you want the contents, you can see. Yeah, the data birth to go and then all the data here. If you want contents, if you want to print. I did any changes, I put it back. Okay, that's what I'm trying to say. See, 0 become male, now 6 we don't call gender. It has been given by gender. And then that's why over here, when you run this one, you can clearly see that male and female. Okay. Male and female, very clear. Okay. Then SG plot, what they were telling us to do. Let me see what they were telling us to do. They say that, okay, then generate simple linear regression that predict this one. Generate 2 simple linear regressions that predict WT18. 18 versus one regression model for the weight for boys and the other one for the predict the weight for girls, one for boys and girls. Why is the 18? How could I know that 18? Where this idea come from? Why this? I pick this one as a X 18. Why? Anybody has any idea? Because of why? they say, okay, get the two regression model for one for boys, the other one for this one, then group, and then group has been that formatted. Okay, let's run this one and see. Later on discuss that why I picked X for that HT18. See, like that. See, where it has been explained by this way for the males and females. But that's what they were telling us to do. Why have we put the WT18 is okay. That's the one that we asked them to be regressed. By whom? By whom? By whom? Which one we gonna pick? See, you can remember. Okay, I'm gonna go back to homework 1 at a certain point. Look at the correlation. Let's go ahead and check the correlation. Okay, and you can get the correlation in 2 ways. See, co princom. Okay, let's go to co and then go to homework 2. The scatter plot. Before we come to the scatter plot. Oh no, it's a scatter plot. So that's okay. Contents okay. For this one, before we come to that SG plot or that regression model, rig model. See, come to rig model. Let's check the correlations among all these. Yes, okay, data out Berkeley. Berkeley, it's not case sensitive. Data out. So I'm gonna get the whole thing all the way up to some. This one MSRP. This one correlation continuous variable. Okay. Why? Let me see what happened. Oh. Okay, I know. Hold on. That's the data set. On this one, on say, go to this one. Oh, this one, that's right. Numbers, only the one with the numbers, not the summer type. Okay, WT2. What happened? W2T correlation among this one. Why did not come? Correlation data. SAS. Never numbers, 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 summer type. Okay, let's try again. Okay. Berkeley, and that's the data out. Berkeley. Levi. Sorry. So let's go ahead and pick the We need the WT18. WT18. Go to this one. WT18. Go this one all the way down and see which one has the highest correlation among with this one. See, highest correlation. Highest one. WT18 has to be regressed against another variable, one variable. So that variable be selected by, see, the one with the 0.7933, which is LG18. That's the reason we use the LG18. Okay, remember that one. I'm going to run this one. Okay, and then LG18. Sorry, no, height 18. I'm sorry. Why the height 18? Which one? I wanna hold on. Did I looking into this one carefully? Okay, this one again. They say that. Okay, generate two simple linear regression that predict W280, but I prefer that one with the one which had the highest correlation. It's not necessary to be highest correlation, but ST18 strength and weight. No, I'm sorry, I'm looking at the wrong place. LG18, no, see, weight LG18, LG18. No, but we use the HT18. WT, I'm looking at the wrong place. Okay, this one. This one is 62, this one is 79. Why we pick weight 18, HT18 to weight 18. It's the weight 18, this is a height 18. Should be LG18. Let's see, more LG18. That makes sense, but still that right after that one, you get the next one gonna be this one. You see, they don't particularly say that one, but I prefer to pick the one with the highest correlation. Okay, either this one or the other one. If you pick, you see, height group by gender, or that you can pick this one. See, since I already have this one, ST Berkeley should be ST18. I see ST18 as a with the weight WC at the edge of this one strength. LG18 has a 0.7933. See, LG18. If you want, you can go with the LG. 18. So scatter plot of weight at the edge and the of the height strength, not a leg circumference, or that to make circumference at age 18, which is called LG18, LG18 group by gender, group by gender, by gender. From the ones of like that, or the other one, the one that I had here. Okay, doesn't matter. But this is the one that with the highest correlation. That's why I ran the correlation and pick the one with the highest correlation one who can regress it. That's okay. It's not necessary to be like that. But here we have ran with the height and weight that makes sense, or that circumference of the leg. That one too. That's the circumference. Oh yeah, that one says TLG. LG means leg circumference. Yeah, like some letter. See, then SG plot and then put the line. See, you want to put the line. See, two lines. Two lines. You can see very clearly. They looks like a parallel. They should be parallel. They should. We're gonna talk about that later on with respect to with respect to the gender, with respect to categorical variable. How we gonna run the regression? See, weight 18 versus height 18. See, regression, two regression lines. They go and intersect or go parallel. If they go parallel, there's no interaction term. This is what I'm trying to say. If these, when you draw this one, if they go parallel, see, sometimes in order to improve, in this case, okay, in our homework too, okay. So that homework too, the way that we have set it up, this what I was talking about, homework too. So then weight 18, estimate B naught plus B1, height 18. Is the model. Is the model. See? So you have weight 18. This one for female one, B naught plus B1 star, height 18 for female one line. And the other one WT 18, height for male, B naught plus B1, HT 18 for male. See? When you run this one, okay. So that one, see. So see, the other one, let's see. So model predict weight, and they can generate the multiple linear regression. And another one we have did this one. See, this one for, see, weight 2 and height 2. I don't think that weight 2 explaining how this is not important. And the predictor variable CLB. Okay, we need weight 18, sorry, weight 18 with HT18. HT18. Linear regression model predict and weight at 18. Not 2. And they're using height at the age 18 as predictors for male category. See, for male category. See, for male category, this is how you're gonna do. See, for male category, you go and where sex equals 0. If you go to sex equals 0, that will take care of that one. See, you don't have to format. Okay, you don't have to format and say gender by gender. They will take care. See, you have V0 for the males. Males, see, V0 and V1. Then you're gonna write the equation for that guy. And then go the same way, you can do that one to 18. So 18. This one is 18. 2 CLB. You know CLB. CLB stands for 18. CLB confidence level for the beta naught and beta 1 at age 18. 18 at age
Hey, Professor.
HT 18 as predicted
hear
for
me?
any new category. Oh, yeah. Okay, go ahead. Angela, go ahead. Hold on. Sorry. Give me 1 second. Go ahead. Angela, you,
Yeah, sorry, I was muted for a second then. Can you do split screen so we can see the code and the results at the same time? That might
oh,
be helpful.
okay. Yeah.
Do you, I can help you. If you like hold the results tab and drag it to the left side of the screen. So
That's what
let me
that
see if I
was.
can draw on the screen. I can't.
You can get the board.
So yeah, if you hold down results,
Okay, hold on. Okay.
hold it down, and then drag it to the right side of this, the other side of this. Yeah, right there. Now let it go.
Let it go.
Okay.
Oh,
And
you
now
see,
you
no?
can click on code on the other side, so we
Yeah,
can
now
see.
you can see, no? Yeah, that's good.
And also, when
I'm gonna make it smaller. Can we make it smaller? Yeah.
you can make that a little bit smaller.
Yeah.
And then also, for the proc reg, is there any difference between using the where statement that you're using and using the by clause? So, go down some more, or where were we doing the proc reg?
Proc, reg, yeah, this one. See?
Yeah, so if after model you do like next line and then by sex
Okay, which
colon.
is 0 for the male, This is for males.
Yeah, but if I'm asking, you can use a by clause that I think gets you the same.
Oh, yeah. Different way. You can do different way. This is not the only way. There are
Okay.
so many ways you can get this done. Oh, yeah. Oh, my God.
Okay, just
So
making
many
sure
ways.
that I that's how I split it, and I'm just making and it looks
Yeah.
the same.
Look
So
the
I'm just
same,
making
yeah.
sure
Yeah.
that,
By that one go at where anyway, that whatever that came to my head that I put right away.
okay. Okay.
Yeah, I can show that those methods too. Yeah. You say put instead of this one where that you can put by just
Yes.
by, you know. Okay, let's run that one too. Okay, hold on. That this one I'm gonna copy. Okay, copy this one. Let's put this one here. You say by.
Remove. Oh no, remove that whole where statement.
Whole where statement. Okay.
Yeah, keep going. All of it.
Okay.
All of it more.
Whole thing.
Yeah, whole thing. And then under CLB, the next line.
Oh, under CLB. Okay. Okay. You can add
By sex and then colon.
Okay.
Or semicolon.
Okay, then we have to define. You don't have to define because the both can be calculated. That's what you are trying to do, no?
Yes.
Both can be calculated like this.
Yeah.
Okay, yeah. Then this title not gonna fit into that one. I'm gonna. Okay, hold on. That's okay.
I guess I should change. I should add I'll add the format in mine and see if that.
I'm gonna just like this. Paste on this one. Yeah, you get the both, no?
Yeah, and I added the format, which I've never seen before. That was really helpful. I added the format statement at the end. It changes
okay.
it to.
And with the gender, no? With gender.
Yes, the gender format.
Okay, this one, no, this one you're gonna add to here. Then the same way like group. Okay, here. That's gonna be helpful because you can distinguish easily, no? This should work. Okay, let's run this one. See, male and female. See, very clear. Yeah, very good. See, very good. See, then you can run that both the regression lines. You can write that based on that one very easily. That's good. Thank you. So yeah, that's the same thing. We write that one, and then they say that fitting.
I also
Yeah, go ahead. Yeah.
on your SG plots, how did you add the regression lines? I didn't catch that.
Oh, okay. Let's go back. Okay, let's go back here. See, I put the for the plot. I put the reg.
Oh, okay. All
That's it.
right.
You just simply say the reg. See this one. Okay. See.
Okay.
Go
So-
together. If you don't put the reg, it's gonna be scatter plot only. See, just the scatter plot. This one. See.
Uh-huh.
Just
This makes sense now for sure.
Yeah. See. See, just the scatter plot.
Mm-hmm.
So then let's go ahead and then add the regression line. You do like that. You're gonna put the reg and then whatever that we need. Yeah. See?
Okay, mine is formatting with the regression lines as well. Thank you.
Okay, good. And then what I'm trying to say that here that when you see that they were they were parallel lines. If the parallel line, there's no interaction. What do you mean by the interaction? Interaction means for this one of them, okay, for the common one, if I'm going to write, let's say that the common formula WT18, okay, V0 plus B1 HT18, like that. Plus, you're going to have a, see, 18 times HT18, see, interaction term. That's the interaction term. That term we don't have if you have a parallel lines. And in this case, in this one, we see the most of the time parallel lines. It seems like but I have a doubt because that sometimes it might gonna go and hit over there, but there's no interaction. It should be like that because most of the case that male and female in this one that they don't have interaction, but sometimes there's an interaction. Okay, doesn't matter. Let's see that, but that's that part we can make that one in detail down the road. Oh, I think that we have that HT18 too separated down, but that's okay. See, same thing, and the rest, what I'm gonna do, I'm gonna wind up over here. That this we can discuss the same, because if you come to the part 2, that part 2 about that we have to do, it's based on chapter 5 mainly. In chapter 5, what we're gonna do, that we're gonna do some kind of a modification to this one. This all that we basically we talk about that one in chapter 5. We're gonna do that curvilinear regression, not the simple one. That when you see that the data being like a scattered in a different ways, like let's say that then we can wind up. Okay, this is what I'm talking about. Then we're gonna linearize by chapter 5. Yeah. See, fit into curves to data. That means mainly that instead of working with the x, we're gonna go ahead and square that one, x squared, fitting into like some kind of parabolic shape, or 1 over x inverse, or log. These are the major 3 transformation common functions that we're gonna utilize. Sometimes in economics, you're gonna take the log on both y and x as well. So far we regress like that. See, look at, instead of x, see, like that, this is a multiple regression. What we're gonna do, we get the same x, we're gonna square all the way up to go to the kth power. But we don't go to kth power in this particular example. Look at this one. I'm gonna draw the scatter plot. Looks like it doesn't fit into a straight line. That doesn't make a better job. Look at this one, like I see parabolic shape. How could you gonna fit in this into parabolic shape? You're gonna run, see, look at parabolic shape, not a straight line. Those are called the curvilinear regression. See, non-linear. See. So that means This one doesn't work. You're gonna square that one. Sorry, that's a test. Okay. Later on, you can suppress it. You can get the C. This one you can get 1 over x, or you can subtract the C. I'm sorry, here. Here, see, here. See, instead of use the x, you still keep the x term. You're gonna square. Or you can take the, instead of x, you can take the 1 over x. Or you can take the ln x, natural log x. Those are the three major that non-linear or curvilinear that regression we're going to talk about in this class. So we're going to jump into that one. That's the one that fitting into the second part of that homework 2. And then homework, the midterm is same like the homework 1. Same like homework 1, we have plenty of time. We can easily go through all these very comfortably Wednesday and Thursday. See, this one didn't work. And later on, what we're gonna do that get a, you feel like this gonna fit in into a straight line, that's okay. But I'm trying to get the best fit. We are trying to get a best fit. See, there's an increase in the cause with experience, but the rate of increase slower over time. See, look at the practical application. You can see there's an increase in cause with experience. These are the number of experiences, number of months of experiences. With that one, you can see that it's going to go up, increases, but slower over time. See, getting slower, see? Slope getting, see, all flattened. See? If that's the case, if you see that kind of a pattern, if you fit this into like a straight line and thinking like that there's an increase in that text.
Will my reflection show?
See, there's an increase in calls with the experience, but the rate of increase slow over time. See, that because of this practical application is flattened over here. This can be easily modeled with something like the parabolic shape. How do you get the parabolic shape? You get the months plus you're going to add the month squared. Okay. See, get the month squared. So that something like that. Okay, I just a little bit show and then we can stop over here. Chapter 4, chapter 5. See, I'm gonna get the tele data. See, I'm gonna get the month and square. I'm gonna square and then add that one. You have a months too. You have a month square as well too. See, like that. So those kind of a thing, and then adding the linear that ln on both sides. See, I got the inverse. You can get the inverse and add to inverse, or get the ln. See, those things you can add to, and then we can talk about that one. See, and Wednesday and Thursday. Okay. If you do, you guys have any question? If not, I'm planning to stop over here. Okay. So if you don't have any, okay. Angela, you have a question?
No, I just forgot not to put the.
Oh, that's okay. That's okay. Okay, then let's all stop over here. Let's meet on Wednesday at the same time, and then I'm gonna. If you don't have any question, I'm gonna let you go. Have a good night, and then stay safe, be well, and see you guys on Wednesday. Take care. Bye bye. Okay.
Bye.
Bye. Take care. Oh, okay. Okay, I can fix that one, Jonathan. I'm gonna go ahead and see. Hold on. Since you are here, let's see what happens. Let's see that why you cannot see that video. Let me go to the videos. Okay, go to the home page. Okay, I'm gonna go to home page. I'm gonna go to class videos. No, 3 videos. See, you can see here. See, class video. Can you see? You should see. Oh, no. Don't go to, that's why I have like a separate class videos. Okay, don't go to Zoom. Okay, don't go to Zoom. Okay, I think you have 3 of them. You're not going to miss anything. Okay, and take your time and finish your homework and then turn in anytime that you want. Okay, don't worry. Everything's in good shape. And if you don't have any question, I'm going to let you go. Okay, see you on Wednesday. and then have a good night and take care. Okay, bye bye. Okay, thank you, thank you, thank you, thank you very much. Thank you.